ready to speak about our course and start our discussion. At first, is both voice and image or video, both of them. Are both of them are good? Do you have both of them? Don't worry, I will upload these lectures in depth, no problem. یک نفر نوشته من انگلیسیم خیلی ضعیفه. خب اگر انگلیسیتون ضعیفه فارسی متوجه میشین؟ خب الان پس بقیه چیکار کنیم؟ من الان باشون با فارسی صحبت میکنم، بقیه میگن لطفا به انگلیسی صحبت کنید. من فکر میکنم خوب باشه این کار بکنیم. من محتوای آفلاینی رو که بارگذاری میکنم فارسی بارگذاری میکنم، کلاس آنلاین ها رو انگلیسی صحبت میکنم. خوبه؟ که انگار هر دوش بشه. بسیار. Okay, now we can start our discussion. As you know, we start our speaking with the embedded systems, and we start at first about this topic, that what is what is an embedded system. And what is the classification of embedded systems? And then we speak about some major applications of embedded systems. And now we want to speak about some main characteristics of embedded system. Okay, what about the main characteristics of embedded system? It means that one embedded system must work in these situations, or one embedded system must have these specifications or these characteristics. The main things of an embedded system is that application and domain specific. Really, an embedded system has a special application. Then it is application specific. For example, we can have some examples, or we can find some examples in internet. For example, biomedical embedded system. And some images about them. We can find some embedded systems in biomedical engineering field. This. For example, this is an embedded system in biomedical field. This is another embedded system with some specific applications in biomedical field. You can see that you must write the field of application of each embedded system. We can write, for example, automotive embedded systems. Then we can find some embedded systems with application in automotive systems. Okay. The other thing, or the other characteristics of an embedded system is that reactive and real-time. Okay, about the reactive and real-time, it is better to write, especially for reactive embedded system. Reactive embedded system. Okay. Reactive systems. It is not good, so good. Reactive systems continuously interacts with its environment. Interaction with environment is asynchronous. Often its response to environment needs to obey time constraints. Often consists of a concurrent composition of processes. These are the definitions of a reactive system. Then reactive embedded system, it means that we have a system that have some interaction between the system and the environment, but this interaction is not asynchronous. It means that it gets some signals from the environment, process these signals, and then reach to a special, for example, solution to the environment and enable some, for example, response to the environment, or for example enables or disables some relays, some switches, or etc. and etc. Then this is the definition of reactive system. The other is that real time. You know that real time. What is real time? Real time, it means that it has a very high speed. This system has a very, very high speed. Then it gets, for example, the signals from the environment, process it, and then, for example, produce some, for example, outputs. These works can be done in a very high speed or in a very low time latency. Okay, this means real-time embedded system. Let me to write real-time 2 for you. Real-time embedded system. like this: real-time embedded systems. The embedded systems which respond to real-time situation with the help of its embedded software or hardware and hardware within the specified time constraints are called real-time embedded systems. It has a very good definition here. Real-time embedded system. Let me to save this image and then send it for you. I think, I don't know, I'm not sure. Do you have any group in WhatsApp or no? Okay, for example, one of you can make a group in WhatsApp and I can send you, for example, some of these figures that randomly we found in the internet. These figures can help us to better understanding. Let me to write for you my mobile number. Please add me to this group. Thank you. Okay. This is the definition of real-time embedded systems. Let me to write another thing, real-time embedded system example. We can find some examples of real-time embedded systems. Okay, we can find some real-time embedded systems. In a system in which work has to be done in a specific time period or hard real time. For example, missile embedded with a tracking system, aircraft, or DVD player, because DVD must be real time to proceed. Okay, I found the group. Thank you very much. To proceed for example, DVD. Another example is here. Cardiac pacemaker. Pacemaker is very important for heart rate or for heart attack. Really, a real-time embedded system. A battery and pacemaker for the patients that have a problem with their heart, and it must done very soon. Another airbag, escape driver and airbag. The system of airbag in automobiles must do at a specific time and very fast, because airbag is related to the immunity of the people. Okay, you can see some such a systems that works in, for example, in aircraft, in biomedical like pacemaker, or for immunity like airbags must work very soon and must and we need to a real-time system. Another thing, this item operates in harsh environments. It is very, very important. Let me write this operate in harsh environment. Then we can write like this: embedded system for harsh environments. Okay. We must know that I want to see some examples about them. Okay, very good, we can find. For example, you can see this. This is a finder in, I think, Mars. We know that Mars has a very harsh environment. It means that the environment is not good. For example, for human, this environment is very, very dangerous. Or we can't send any human to that environment. Then we need to a system, to a machine that works for us. If you look at an example for harsh environment, for example, Mars have a very, very harsh environment, and we have some embedded systems here. One embedded system for taking photos, for taking photos and, for example, videos from the environment. Another embedded system for controlling this machine. Another embedded system for example, charging this machine. And controlling the energy saving of this machine. Then you can find some embedded systems in this machine for harsh environment. And here, what is harsh environment? Many embedded systems do not have a controlled environment. For example, heat from combustion or limited cooling. it is a harsh environment. It means that this environment is very hot. For example, vibration and shock. Another environment with high amount of vibration. Lighting and electromagnetic interference or electrostatic discharge. Or dirty power supplies. For example, some power supplies that human can't work in this environment. Water and corrosion. It means that, for example, we have a system that must work, for example, in water, and we need to a system that must work, for example, in high depths of water, for example, in sea, for example, in ocean, for example. Fire is another example of harsh environment. Shipping damage, like water, for example, environment. Physical abuse, for example, drop test or another thing. And all of them are some examples of harsh environment. And hardware design challenges, for example, accurate thermal modeling or use of different components for each design depending on operating environment. Then you can see some good examples about harsh environment. Another thing about design constraints. Design constraints of an embedded system, really. For example, small size or low weight, you will find it soon later in the slide. Low power, harsh environment, for example, some examples of harsh environment: heat, vibration, shock, power fluctuations, RF interference, lighting, water, corrosion, physical, for example, abuse, and something like that. Okay. Another thing is about distributed embedded system. What is a distributed embedded system? Distributed embedded system. It is very small. I can find the figure, it can be good. This figure is good because it is about a review on performance of distributed embedded system. Let me to know. Yes, distributed embedded architecture. An example of a distributed embedded system. You can see this. In this example, we can see a network here, or connection to the network, and we can see some processing elements. What about the processing elements? For example, here a microcontroller as a processor, or the producer of inputs and outputs. Another processor is a 16-bit CPU, central processing unit, and another processing element. Another one is ASIC. ASIC, it means application specific integrated circuit. It means that it is an IC with special application. Maybe it can process something, maybe it can't process something, and only, for example, gathering the information. Another one, DSP processor, for example, it can process information, but in DSP applications it can work better. And another thing, sensor and actuator. Sensor and actuator, both of them are not really processing system, but they can prepare proper information for us. Okay, this is an example of a distributed system. Let me to save it like previous images, and I will send it at the end of the class. Another example, distributed embedded system, like here. Distributed embedded system. In this distributed embedded system, you can see, for example, a very complex system. But this system has two parts. You can see this interfacing part, for example, interface, power PC interface, speech input and output, buttons for controlling, LED matrix, eye controller, face tracking, people detection, and all of them get all the information gathering by this special scenario for or scenario controlling, and all the information will go to the processing part. This is a processing part. This processing part is a PC interface, and then we can see a camera driver, laser driver. It will be the output of the processing part. Okay, the controller scenario, and then producing proper outputs. The producing proper outputs will go to, for example, bumper driver, odometer driver, laser driver, camera driver, and something like this. This is a special example of a distributed embedded system. Another block diagram of a distributed embedded system, like here. You can see a bus between some parts, for example, sensor, dedicated link, data acquisition system, speed link, data pre-processing really, local bus, signal processors, external system interfacing, multiple display units, display processors, supervisory or supervisory control, human machine interface, bus controller, and data processor. All the, maybe an embedded system is composed from some of them, or another embedded system may be composed from all of them. This is general. Let me to save it again. Save it for sending for you. Okay. Another thing is about the small size and weight. You know that it is better for embedded systems to have small size, and we have small weight, small size for good application and applying them in different situations, and small weight for portable. Power concerns, it means that it is better, it is very better, it is preferable for embedded systems to have low amount of power consumption. The other is single function. We know that they have application specific, and maybe they have or maybe they are used in only one function, and we call them single function. Complex functionality, okay, it is better to search complex functionality for embedded systems. Okay, embedded system with complex functionality. I have some general things, for example here. No. Okay, we can find another thing, complex functions. Complex function embedded system. Let me write examples. Okay. We have some embedded systems here. You know that some of the embedded systems are very simple, but if we have an embedded system with complex architecture and complex functions, we can say complex function embedded system. What about the complex function embedded system? For example, if we use an embedded system for as a neural network, it is complex function. If we use an embedded system for a robot, it will be complex function. Then you can see to the application or the functionality of an embedded system, and we can really specify that its functionality is single or complex. And safety and critical. Safety embedded systems, it means that it is better for us to use from embedded systems in harsh environment to save our safety. Or we can, for example, use from embedded systems for safety of the people. For example, here we can write it like that. Embedded system, safety, application. Okay. For example, airbag is really for safety. For automotive systems, airbag embedded system is very useful for safety. Or we can find another embedded systems, maybe. No. Safety application. Let me write it only safety. Or another application of embedded system as data security system, as data encryptor, and another safety application of embedded system. Then we can find some examples of safety in embedded systems. Okay. And then we can find another thing, quality attributes of embedded systems. It is very important, because if we want to speak about the performance of embedded system, for example, we have two embedded systems, system 1 and system 2. We say that system 1 is better than system 2. Why? We must have some quality attributes. And what about the quality attributes? We have these quality attributes. For example, response, throughput, reliability, maintainability, security, safety, testability, and etc. We must know that which of them is better in system 1 or system 2. Okay. Then we have some quality attributes of embedded systems. Let me write it in internet, in Google, and see if we have any. Yes. For example, maintainability. Here. Characteristics of embedded systems. No. embedded system. All of them are about your characteristics, not about the quality attributes. Okay, we must find one by one. Okay, the first one is about the response or response time. Then let me write it. Response of embedded systems. Well, no. What is the definition of response time really? We can see this here. For example, let me to save it at first. And show for you. Okay, we have a real time. We want to know about the real-time embedded system, for example. We have here the time axis and a deadline here. Soft real-time, it means that the value or usefulness is up to the deadline. After the deadline, the usefulness will be low, but we need some to system to decrease the amount of value. But in firm real time, we have an operation like the ideal expectation. In hard real time, we have an operation so better than the expectations. You can see that the value is decreased very more than the expectations. Okay. And response of embedded systems. Another graph for response is here. Response time analysis. Let me just save it. Okay, response time, demand response time here. In demand response time, we have a decrease here and we have an increase here and then decrease here. If we have the decrease before than the demand response time, we have a low system. If we have an increase, if we have a decrease after this, we have high the normal time is here, really. Time concepts of embedded system, which of them is better? Our friend Excuse me, I have a problem with my internet line, and both voice and video have a problem. Do you have my voice? And about the image, let me to share my screen. I don't know how many minutes we have we lost our speaking. How many minutes? Do you know? چه مدت هست که صدا رفته؟ اینو میتونیم بریم بگیم مثلا تو چه متنی بودیم، کجا بودیم که صدا رفت. خب ببینم نه الان که صدا هست. نه میخوام بپرسم که چند دقیقه هست که صدا قطع شده و الان و از کجا در حقیقت صدا قطع شده، من کجا بودم که صدا و تصویر قطع شد. میتونیم بگیم خب چند دقیقه فقط بوده؟ 5 دقیقه 4 دقیقه بوده. بسیار بسیار okay, no problem. Okay, now I start from quality attributes of embedded systems again. As you can see, response, we want to introduce you some quality attributes of embedded systems. It means that each embedded system have some parameters, for example response time, throughput, and something else. If these parameters are in good state, we can call this embedded system good, and if these parameters are in weak situation, we must call embedded system weak. For example, response time of an embedded system. Response time of an embedded system shows us the speed of embedded system, and excuse me, one of the students want to speak. Mariam Sattar Jabbar. Yes? No. I don't know. As a guest. And throughput, it means that producing output, the speed of producing output for embedded system. Reliability, it means that the embedded system can work in different situations, in different places, in different environments, and produce a good or proper output. Then we can call this system a reliable system. Definition of reliability, we can see the definition of reliability here, for example, like this, if we can see. Reliability. Reliability is the probability of a, it is not good, let me to write another thing. Reliability, probability of system working correctly provided that was working at t is 0. It means that reliability is a probability, but the probability of correct working really. Another thing is maintainability. Maintainability is another probability. Another probability of system working correctly. The time units after error occurred. And availability is another probability of system working at time t. Then these three parameters, reliability, maintainability, and availability, all of them are probability. Probability of system working. Reliability is the probability of system working that works correct. Maintainability is the probability of system working that works correct, but after an error. It means that it shows us that the system can correct its error. For example, an error occurred in the system. We, for example, correct the system and the system work again. And the system must work correctly. How many times this system work correctly? It shows us the maintainability. And availability is the probability of system working. How many times this system can work good? Then you can see in the slide reliability, maintainability, and availability as another parameter. Another parameter here, safety. It means that no harm to be caused, in the system. And security, it means confidential and authentic communication. Confident and authentic communication with other systems in the environment, for example. This slide is very good, and let me to save this image. It is very good. Okay. For example, about the reliability, maintainability, and availability, let me to write more. Reliability, meaning, for example. As you can see, the quality of being trustworthy or performing consistently well. For a system, the quality of performing consistently well, it is reliability. And maintainability, correct defects or their cause. Excuse me, let me to see this better. In engineering, maintainability is the ease with which a product can be maintained in order to correct defects or their cause, repair or replace faulty or worn out components without having to replace still working parts. As I told you, if we have an error in the system, we can correct this error and the system continue correct working. Okay. I can't hear you, doctor. One of the students write that there is not any sound. Do you have my sound? Okay, very good. Reliability. The probability that the system will not fail to perform its assigned function. Yes, it is good. It is another meaning. Sir, all this information will be available in the PDF of this lecture. Yes, I have a PDF from the embedded systems, and all of these are in the PDF. Yes. Okay, after this we have testability and debuggability and portability. Portability, it is related to have a system that is portable. Time to prototype and market, it means that we have an idea, we make the system for this idea as a prototype, and then we reach this system to market for business. There is a time between idea to business. If we have a little amount of time, then this idea can be a fast marketing really idea. If not, it will be low. Then if we have a system that has a low amount of time, it will be very useful. Okay, let me go to the last slide. Elements of embedded system. As you can see, the elements of an embedded system are here. Input port, output port or output ports. Input ports are like sensors, and output ports are like actuators. And we have some communication interface, for example USB port, maybe serial port, SPI port, and etc. A memory for saving information, and maybe have a firmware like software, a firmware for the system. Some other supporting integrated circuits, maybe a special ADCs, maybe a special amplifier, and etc. And a core, a system core. And you can see that this system core is really a processor. Some processors, for example, let me increase the figure. System on chip, controller, microcontrollers, microprocessors, application-specific integrated circuits, DSP processors, and FPGAs. You know about the microprocessors and microcontrollers, but up to now we don't speak about the FPGA. What is an FPGA? And how can we program, or how can we implement on FPGA? Then the next slide is this, and it is our goal: embedded system design with FPGA. We want to know this because we know about the microcontrollers. You know about the microcontrollers, about the microprocessors, but we don't know about the FPGAs. Then now we want to speak about the FPGAs. Okay. Then after this slide, we end embedded systems here, and we will start FPGA and VHDL. I mean why HDL, types of HDL, and etc. Okay. Then after this session, in another session or in another online class, we will speak about the FPGA and VHDL. Okay. Is there any problem or is there any question? من فایل PDF رو هم توی سایت قرار میدم. مشکل نداره. توضیح دادم، حالا باشه بعدا هم توضیح خواهم داد. چه توضیحاتی؟ گفتم امکان داره توضیحات فارسی باشه. چه توضیحاتی منظورتون هست؟ مثلا شما رشته کامپیوتر هستین، الان تعجب میکنم چون گروه ها فرق میکنن. چطوری شده شما این درس رو اینجا گرفتین؟ فایل آفلاین یک تعدادیشون فارسی هست. اگر همش رو فارسی میخواین باید بین حضوری از خود من بگیرید. Okay, about the degree of the course. تماس بگیرید، ما تو بعد این کلاس نباشه لطفا، هفته آینده باشه، چون دیگه الان تعطیل هست، منم درگیرم. About the degree of the course. Yes, the degree of the course is divided into 3 parts. One part and main part is final exam. The other part is you're working in the class. After 2 or 3 online classes, I will ask from some students. Okay? And the last one is a research. I want you to do a research for this course. Okay? باشه، مشکل نداره، همون هفته آینده بفرستیم. برنامه تماس بگیریم، یا مثلا چهارشنبه صبح تماس بگیریم. که تعطیلم نیست، من دانشگاه هستم، میتونیم صحبت کنیم. Okay, very good. If there is any other problem, please send it. If not, I will end the class. یک نفر مترجم انگلیسی به عربی، من نمیفهمم یعنی چیکار کنیم؟ یعنی چیکار کنیم؟ من انگلیسی صحبت کنم، اون به عربی ترجمه کنم تو کلاس؟ اگه بقیه دانشجو موافقن میشه این کارو کرد. از خود بچه‌ها باشه. کسی هست از بچه‌های شما که ایران باشه، عراق نباشه؟ میگم کسی هست که ایران باشه، عراق نباشه؟ خب این هیچ. خود شما که میگین یک مترجم باشه که به عربی ترجمه کنه، آقای یاسر امارهات هم از دوبیدی درسته؟ خود شما فارسیتون خوب هست؟ خوب متوجه فارسی میشین؟ خب اگر واقعا خوب متوجه میشین میتونم به شما فارسی بگم، شما توی کلاس به عربی برای همه بچه ها ترجمه کنید. دانشجو قبول نکرد. بسیار پس هیچ. Okay, I will speak in English. One of the students suggests that I speak in Persian and he translates my speaking in Arabic. But I told him that if all the students will accept this, you can do this. Okay? One of the students want to speak at the class. خانم زینب حمید کاظم
Please doctor, all
سلام.
students understand English, but one or two speak Farsi. We want the lecture in English, please.
No problem, I speak English in the class and the lecture is English too. Maybe some offline classes are in Farsi, maybe.
Translation to
And
translation.
as I told you, yes, as I told you, one of the students suggests that I speak, for example, Farsi for him, and then he translates in Arabic in the class. But I told him that all the students must accept this suggestion.
All students write English and students speak Farsi. We translation English to Arabic to understand. Okay. Thanks.
Okay,
Thanks.
okay, no problem. Hello. Okay, if there is any other question, please write it. If not, well, I want to end the meeting and the class. Okay, thank you, you're welcome, and goodbye.